Tak ďalšia prezentácia. Attila Mészáros z Red Hatu nám porozpráva o všetkých možných spôsoboch, akým spôsobom môžeme implementovať Kubernetes operátory. Tak okay. Je to tvoje.
Ďakujem. Thank you very much. Hi, welcome everybody. I'm Attila Mészáros, engineer at Red Hat and maintainer of Java Operator SDK. But today I would rather tell you more about all the other ways, or also a little bit of Java Operator SDK, but also the other tools and frameworks which you can use to implement Kubernetes operators, their benefits and limitations, and other factors. But I also want to give you a little bit deeper understanding on some of aspects of Kubernetes operators and the pattern. So this is a Kubernetes meetup, but I still will a little bit define what is an operator. I assume most of you already know. But it's basically, in Kubernetes, you have these built-in types, pods, deployments, config maps, you name it. But you can create your own custom type. This is called custom resources in Kubernetes. And how does it look like? It basically you have to do is create a custom resource definition, which is a built-in type, where you can specify your basic name of your new time, its group, and the other properties that you usually require, like a spec and the status. And in our example, we will use an example to deploy a simple Redis instance. And we require just one input if it by default requires authentication. So Redis is I assume everyone knows, it's a little simple key value store, in-memory key value store. And basically, authentication can be done in a very simple way in Redis, and if this flag will be true, then we set it with an API call. And the status is just if it's ready or not, deployed fully or not, so it's a kind of a simplified version. So after we deploy this or apply this custom resource definition, we can use new custom resources, and basically all the API capabilities of Kubernetes works with these custom resources. You can get them, manipulate them with kubectl, and all the watches are back, and everything applies to them. API server is kind of extended dynamically. So what operator does is just watches these custom resources, checks their spec, which is a spec is basically a desired state, what we want to achieve, and the controllers try to make the actual state of the cluster or other resources closer to these desired states. So that's the idea of this control loop behind operators, but also in general, not just in Kubernetes. So more technically in Kubernetes, what's happening that we are running this controller, it communicates with the API server, checks these resources, as this very skillful image indicates. So we receive the events, and these events are containing the whole resource. So not just the modification, diff of the resource, but always we receive the whole resource. And in our controller, basically, as a developer of an operator or a controller, we just implement our reconciliation logic. And if something is not in a desired state, we try to update either Kubernetes or some external API. So this will be a little bit important for us. So when we are doing some reconciliations, we can usually we are calling Kubernetes APIs, but some of the operators are calling external APIs, like AWS creating an S3 bucket, or just already running pod and accessing your pod's API. In our case, it will be Redis, so we are going to contact Redis from an operator. So that will be kind of a deal for us if some operator is calling external API or just internal APIs in some frameworks. So these controllers are running simple processes or pods in Kubernetes, and basically doesn't really matter in what language, what framework are you implementing the controllers. It's one thing that they want to follow is this operator pattern and some other characteristics that we will touch on, but basically the same principle holds also for the built-in Kubernetes controllers. So in Kubernetes, the deployment controller or stateful controller works exactly the same way. It's a process, communicates with the API, makes changes to the objects or resources through the Kubernetes API. And if you know projects like Crossplane, it's basically all about these external resources. So managing resources on cloud providers and others instead of Terraform or other infrastructure as a code service. I want to talk a little bit more about the communication, how this happens between the controllers and the API server. And there is a component, basically every Kubernetes controller that is on the client side, so on the controller side, that maybe is a little bit hidden for you, for example, in Go. It's informer. So informers are part of the client libraries, like for example, in Go client or Java clients, not part of the operator frameworks. They just use them. And they are responsible to basically properly implement this communication of receiving events from the API server. So not going too much into details, but one of the big points is that it opens the WebSocket, receives the events with the new resources, and stores them in the local cache. This local cache is very important from multiple aspects, but for us, it will be important because you are able to then access the cache locally in a controller. So you won't have to query API server for a fresh state. You just always use a local cache on the controller side. And if you receive an event, the informer, you can register an event handler that going to basically handle these events, and you can put there your custom code. So I will show you codes because it's easier to understand how does it work, how is the API, but I'm not going to run it because we don't have simply enough time for that. Trust me, it works mostly. Going to do it in Java, but it's identical basically in Go. What we are doing with informers is creating a client, a Kubernetes client. The client, we can say that we want to, for every Redis instance, in any namespace, have an informer, and the informer, we can set this event handler. And we receive here the events on add, on update, on delete. But basically what at the end happens is we call the reconcile with the new version. In the reconciliations, we don't really work with historical versions. It's a bad pattern in Kubernetes controllers. But theoretically, in informers, you would be able to do that. The old objects comes from the cache, the new is from the new event. So it's simple as this. If you will run this on every change of Redis instance, we will write this simple message to the console. So these are basically the informers for us, and there are a little bit more generalized concept in most of the frameworks, but for sure in Java and in Go, it's called event sources or source in controller runtime, which is an abstraction for non-Kubernetes objects. So for the same pattern to have a local cache and watch some or track some other resources outside the cluster, like a state of an RDS instance in Amazon or any other service, event sources is an abstraction for that. So, but the principle or the goal is to follow the same pattern to have a very efficient reconciliations. And how does it look like? It basically, in a controller, we're checking these caches. If the desired state is not there, so some resources we manage, for example, a deployment for our Redis example, then if it's not in the cache, we are going to create it. If it's already in cache, we just compare if the desired state is the same as the cache state. And if it's not the same, we are going to update it. If it's the same, then we are going to just ignore it. So if we are ignoring it, it means that actually no API call made to Kubernetes API. So that's the point. If you have hundreds of thousands of resources and there is nothing to change, we don't make any necessary API toward the Kubernetes. So that's basically the heart in the every Kubernetes controller. So we usually get this question if it's enough to implement informers just for a controller or for an operators. And so in our sample, we will manage 4 resources. So it's actually never one informer or never one event source. We are always tracking all the resources with these informers or event sources. We have always all of them in the local caches, and these are triggering the reconciliations. So triggering your logic. for every resource. So if a service changes, we will reconcile every resource again. But since others are not changing, we can, and these are on cache, we can make this efficient reconciliation. So there is no API calls, but we are making sure that every resource that we manage are actually the target state. So do we need an operator framework? It's definitely yes. So I would never start with informers, with not even the simplest cases. So there is obviously the concurrency issue. We don't want to have parallel reconciliations, even if the events are coming from multiple sources. If we have one Redis custom resource, there are multiple events coming in. We don't want to reconcile them in concurrently. We want to have just only one reconciliation for one custom resource. Of course, concurrently running the other custom resources, but not for that one. So generally, these operator frameworks are already modeling this domain very nicely. They have this all kind of capabilities for metrics, finalizers, rate limiting, error handling. There's a huge list that makes sense to work in operator framework level, not on some informers. But informers are still, and these caches are the heart of these controllers. So I will name these two major, the Go stack and Java stack. Usually we have these clients, both for Java we use in Java Operator SDK Fabricate client, and Java Operator SDK implements this controller runtime where inside of the SDK, which is basically about the framework to make your operators and all the necessary components. And we support in Java Quarkus and Spring, and also have a plugin for Go Operator SDK, the scaffold projects. Same happens or very similar in Go, that there is a control runtime, which is a core library, and KubeBuilder Operator SDK brings additional facilities. But Operator SDK also supports these two additional ways to implement operators, the Helm and Ansible. So just to give you a notion again about the complexity, how hard it is to implement, for example, this Redis that will manage these four resources, deployment, a service for the deployment, and the secret, which will contain a password for Redis, and setting up this and reconciling. I will show you an example in Java quickly. So in Java, it's really, you have to ignore everything. You can ignore everything from these four classes, and from these four classes, this is in Quarkus, not pure Java, but font bigger. I'm not sure. Where is that? Not using this. Where is that? Sorry, not really.
You can go presentation mode. Yeah.
View, appearance, and presentation mode. Yeah. Okay. Now I don't know if. Okay, so we have these three classes: the custom resource. Some of them just implement the custom resource, and then we have the reconciler, which is basically the only class you have to implement with two interfaces. And one is the event source initializer will provide you these informers. So we say that we are going to watch the secret, deployment, and service. And that's it. Basically, this is a registration of these informers. And then we have a simple logic in Java to reconcile these resources. So we reconcile deployment, service, and we wait until the deployment is ready. In the spec is required authentication, then we reconcile out of the secret, we create if it's not there, and set the password in Redis. So setting the password in Redis is just calling the API with the Redis client and setting the password basically with the require press command. And generically, the reconciliation is same for every of these resources. It's a little bit simplified version. We say that we create this deployment if it's not exist. And basically, usually that's happening like with just using a template where we are filling the missing field. So in our case, we fill the name and namespace, but there is already a image and predefined, and it's running Redis in memory mode. So basically, that's it. So it's, how do I exit presentation mode? Basically, it's just to give you a sorry. So basically that's it. So this is, as you can see, it's not really that complex to implement this logic. So using these generic frameworks is definitely a very safe choice. You won't hit any more. It covers absolutely all use cases. But if you are not a developer or you are more the platform side, it might be harder you to start with. So you need to really proficient in the language, and not all languages have these major operator frameworks. So we will a little bit take in now on other alternatives, and which are on market. There is not much more. We will start with Metacontroller, which is a very interesting concept, comes from Google. And this is another basic way to just not use a generic framework, but use a kind of a different, that basically catches it from different aspect. It says that we have a generic controller, it's called Metacontroller, and we can configure it with Metacontroller configuration resources. And how does it work is that basically you set up these watches or informers, and Metacontroller will make an HTTP request instead of calling the reconciliation in a code. But basically, it makes a HTTP request with all the resources with the parent, the Redis instance, the secret, deployment to a web service endpoint. And what you have to do is return the target state. So the target deployment, the service, or the secret. And Metacontroller will do all the communication with the Kubernetes API. So this is interesting from a perspective that it's not bound to any language. You can implement this interface in any language you like. Maybe that language doesn't have a full-blown operator framework. So this is basically kind of the big plus of this approach is language independent. So just give you, again, a little bit look on the code. So it's at the end very similar that you would implement in a generic in Java. You just receive, you are accessing the caches not through APIs, but you are accessing the resources from the request. So we have the request which contains the Redis instance, and here are the children, basically a map of all resources, all the deployments, and the resources that we manage. And we are doing the same. Actually, we can do it the same to set the password if the deployment is ready. This endpoint will again code on every change of these resources. So Metacontroller watches these resources, and all we have to do is return the desired state of these deployments and services, and maybe set some status that we also return in the response. So actually, the complexity of this implementation is very similar to the one with the generic frameworks. Just to give you a look also on this, how you are configuring it, all you have to do in our example is just say that I have a parent resource, which is the Redis instance, and I have these 3 child resources, a service, secret, and deployment, and the URL, what to call. And basically, automagically, everything works from this point to you. And what you have to do is just deploy this Metacontroller and deploy this or apply this configuration, and it will call this endpoint. So what are the problems with this? The one is that they are explicitly stating in the docs that if you are a controller which watches every resource on a cluster, like every pod, so every config mess, this request can be very huge. So it's not really fitting that use case. And in my opinion, at least, it doesn't really fit for the use case when you are managing these external resources. So when you are not managing Kubernetes resources, there is no way to tell Metacontroller that you are watching resources outside of the cluster, which is definitely possible with the generic frameworks. So it kind of has this limitation that you can hack it, you can call the API of Redis, but doesn't have these event sources. You cannot tell that trigger the reconciliation when there is we are managing an external resource, not a Kubernetes resource. And there are some other limitations. We cannot manage cross namespace references. Like if you have Redis instance in namespace A, I want to have the deployment in namespace B, then this is not possible. So there are these other minor limitations. But otherwise, it's one other way to go and maybe good to start with. There is another way. It's called Helm Operators. And Helm Operators, the name is, it's create a bridge between custom resources and Helm, or operators and Helm. Probably all of you know Helm, right? Is there someone who doesn't? Okay, so it's basically what does, it maps the spec of the custom resource to the values of a Helm operator. So just give you a little insight. All I had to do here, just very quickly, is to put the required authentication in the values of Helm, and then this can be used in a Helm chart as you normally do, and basically don't create a secret if this is false. But basically, this will generate you a binary or an image, and you can deploy it, and it at the end maps the value from the spec to this values, the Helm chart, and execute and apply the Helm chart. It does this very efficiently. There is lots of magic with the caches working in the background, so it really becomes a very kind of optimized way to managing this Helm chart. On the other hand, it's just powerful as a Helm chart. So it just can work with Kubernetes objects. Helm charts just can use these values from the spec. So in compared with Metacontroller, it's really much less powerful in the sense that when you're doing reconciliation in the Metacontroller, you are having all the related resources, child resources, deployment, and you can make decisions based on that. You have that available in a generic programming language. In Helm, you are still using this, you are just using the custom resource spec, nothing else, and based on that, you're generating the resources using a Helm chart. So who is this for? To be honest, what I could imagine is if you have a service, which is this a very simple deployment, you want to give this experience providing an operator for your service, you can set up this within minutes and generate an operator and provide that an operator hub. And if your service would require a little bit more complex operator, just replace the controller. So if you don't want to work with Helm charts, you want to have the operators, it's a way to replace that or basically just use it instead of that. But otherwise, it's not really more powerful than a Helm charts, other than it manages these watches out of the box for you for every resource. So you can configure that, but here you have basically a watches YAML event. This can be configured how the watches and informers works, but by default, it creates informer for every resource that you create with the Helm chart. So that part is at least very efficient. Okay, and the last one is Ansible. So Operator SDK provides also a bridge between Ansible and basic operators. And how does it work? It's also a very similar concept to Helm, it's just with Ansible. So there is a project generated for you, and all I had to do to implement this example is just to implement this tasks file in Ansible. Although I was working with Ansible first time in the life, so it might be not that efficient, or some Ansible magician can do this better. But Ansible has support for Kubernetes resources. So you can very easily just template this. You can use the resources from the variables from the spec in these Ansible operators and manage these resources. A little bit more problem was with the Redis part. But obviously there is also a Redis support in Ansible, so I had to use this general Redis module and set the password from the secret. On the other hand, I had to fetch the Kubernetes resource and get it to some state, set the fact, basically the secret, and this will use, I guess, I think the cache, so it doesn't really go direct to the Kubernetes, but it's a little bit, can be cumbersome to manage these resources with Ansible. On the other hand, but you can define watches and same like this, and it works in a smart way that you handle watches and finalize and caches, uses caches if it can, and there are metrics, finalizer supported, and it's really kind of a feature complete as it can be regarding to Ansible. So who is this for, basically? So as a Java developer or Go developer, I wouldn't probably start writing operator in Ansible. But if you are kind of expert on this Ansible, then this might be a choice, and you have an operator that really fits this use case. It always sometimes can be hard to tell, but it's there for you. You can use it. It's if you are an expert in Ansible, probably this is a lower barrier to start and create an operator than from scratch in a generic programming language. And Operator SDK documentation states that Ansible operators, of course, are as powerful as Go or Java or any generic programming language operator, although maybe the optimization, performance, or expressiveness, it's maybe even, might feel even hackier, but not, I guess, not all the cases. And there are few exceptions or few corner cases when it won't work. Simply, it's not enough to cover. They are explicitly stating also that. Okay, so basically, this is mostly I wanted to say on this talk, and I guess we have a little bit more space for questions. Yeah, thank you very much.
Okay, thank you very much for the presentation. And I'll check the Slido. And yeah, no questions online. Anyone here in the audience want to ask something?
Any questions about operators or about these frameworks, please?
Yeah, one. Yeah, how do you implement complex logics for a custom resource Ansible operator?
Yeah, that's a good question, and maybe I'm not the best person to. This is also basically an Ansible question generally. So in the same way as you would do it in Ansible. So for example, based on the CR, so you have this require authentication, all the inputs from the CR there for you. So you, for example, I'm creating the secret only if the require authentication is true. So you can use just these Ansible idioms and structures and access all the information or input from a custom resource spec. And then basically just have these tasks based on that and have it in the Ansible way. I can imagine this can be problematic in some cases.
Primarily, what is the problem? Ansible is a declarative language, so you just program what do you want and you don't care how you will do it. So theoretically you have to create some plugin for Ansible if you want some custom logic flags, and this is a little weird because theoretically I can program it directly in the Golang. So it doesn't make sense for me use Ansible for full operator with very hard logic.
Yes, with very hard, yes. So it's, but also there is, you don't have to code most of it. So these external APIs, there are already modules for Ansible there. So you can just reuse them, and for Redis, I found this, it's part of the core, some general community module. So you can just reuse those modules and you don't have to think about on those. If there is something you want to, for example, check if the password already exists and do this idempotent, in all cases, the idempotency might be a problem actually. So but otherwise, there are the modules for you. And I don't know. I'm not sure how it is with Ansible in all cases with idempotency. I think it's not always idempotent. At least the Redis wasn't. But it's not really. I'm not sure if this can be actually made idempotent. This one operation, our module.
Yeah, we have another question on the Slido. Whether users are expected to write custom resource definition in YAML.
I think there is expected that you write them. So in Java and Go, you are generated from source code, or in Java we have other way around, that we generate source code from CRDs if you prefer contract first. But it generates you a very generic CRD, and then as far as I know, there is no way to nicely do it and generate it from the code. And basically, there is no information in Ansible how to basically generate that, or it will be extremely hard.
Okay, and the next one, what do we need to consider in order to choose best programming language for an operator?
I think you have to first choose your programming language when you can code. But if you can code in more programming languages very nicely, then probably the maturity of the frameworks I would choose. So if but for example, we could do a comparison between Java and Go, and there is almost nothing that would miss in Java. And actually, in Java Operator SDK, we have features which are not in Go, because simply Go has this actually multiple. So Go has this philosophy to keep it simple as possible. For example, we have high-level abstractions in Java Operator SDK. We have something like dynamically changing following namespaces, or which are checked namespaces if you don't check the whole cluster, but some namespaces only, and things like that. So the maturity is probably the leading. And to be honest, I think there are some for Rust. Python seems to be very mature, and Java and Go, of course. I don't know. There are some others, like there is also TypeScript or Node or other languages, but I won't judge them here. Yeah, you have to do that.
We're gonna hear Python in a minute. Yeah, another question. Whether it's a metal operator like a SPOF?
Is a metal operator single point? Is a single point of failure. So in generally, this is a problem in Kubernetes. So Kubernetes operators, if operators stop working, then our Kubernetes stops working. So, but if deploy operators are deployment, the pod stops, it's restarted. And the whole design of these operators and basically these informers, one of the reasons why there are those caches, is if it starts again, actually in this case not, but so if it starts again, it reconciles all the resources. So basically this is built in the architecture and the setup that operator will stop, they will fail, we will deploy new versions, and it will basically, it's very resilient. And also these connections with these watches are fails. Actually here, the informer will every 5 to 10 minutes close the connection and reopen because of a bug there in Kubernetes. So but it's basically designed this way to be resilient.
Okay, and the last question, a bit more funny. Who likes to write operators? Do you like writing operators in Kubernetes?
Do you like writing, or do you like the pattern?
I don't know what was the intention, but probably the writing.
I'm mainly, what we used to say, we mainly implement the operator framework, so I like writing operator frameworks. And I can do that, I can say, and we are in contact basically with multiple teams like the Flink operator, which is kind of market lead, and Keycloak and other operators which are implementing that and helping. I think it's fun, and in Java we have this high-level abstraction which makes it much easier to write these operators. I did not discuss it here in this talk, but there are lots of problems we can generalize in libraries, and we support that. So it's actually, you don't have to write from scratch these reconciliations and stuff. So it's much easier with high-level library. That's kind of what's it in Java, and I think you usually do it anyway when you write complex operators and multiple like in cross-plane. So it's not like you write everything from scratch all the time. This logic around it, you have usually the high-level abstractions. But yeah, I think it's fun.
Okay, thank you. We're out of time, so if we have any questions in the audience, you can just pass them to Slido and we can answer them later.
Yeah, or stop me anywhere.
or just stop and just grab Attila somewhere out there. Okay, thank you very much.
Thank you.